Okay, and I'll just give it a minute to let some attendees filter in. Okay, got a couple people filtering in here. All right. Well, now that it's officially 3 o'clock Eastern time, I'll go ahead and get started with just a brief introduction for everyone here today. My name is Laura Shevlin, and I'm an educational courseware specialist here at Hawks Learning. And today our speaker is Mori Jamshidian at California State University, Fullerton. He is a CNSM Distinguished Professor in the Mathematics Department at CSUS and serves as a graduate advisor for the Master of Science in Statistics. His past positions include Associate Professor of Statistics at the University of Central Florida and Senior Statistician at the BMDP Statistical Software. His area of research is broadly in computational statistics with publications in major theoretical and applied journals, such as the Journal of American Statistical Association, the Journal of Royal Statistical Society, and Psychometrica. He is currently an associate editor for the Journal of Computational and Graphical Statistics, and in the past has served as an associate editor for the American Statistician, Journal of Statistical Software, and the Journal of Statistical Computation and Simulation. His current activities include research in statistics education and the development of statistical software for teaching statistics. We are excited to have you here with us today. If you have any questions at all throughout the webinar, please enter those into the Q&A box at the top or bottom panel of your screen, and Mori will address those at the end of the talk. But for now, I'll go ahead and pass it over to our speaker, Dr. Jamshidian.
Thank you, Laura. I hope everyone is doing well. So let me just start with sharing my screen here. So can everybody see my screen, I am assuming? Yeah, all right. So, so I'm going to talk about Rguroo today and how we have been using it in our classroom. Rguroo is a statistical software that we released just past August, and we have had tremendous response, and people that have been using it, they have been very happy. And I'd like to give you an overview of Rguroo, and let me begin with how Rguroo came about. So in about 2010, I was appointed as the coordinator for introductory stats courses. And at that time, of course, we were not using a specific text, or some people were using calculators. There was not really many people that, there were not many people that were using software. And of course, you see the calculator, I put a no calculator sign there, and I don't mean that calculators shouldn't be used, but really to do statistical analysis, I think using software in a classroom is necessary. So at that time, we decided that, okay, so we should probably think about a software to use for our classrooms. And so what we did was, R was free, and we thought, okay, maybe we can try using R. And in fact, for a couple of years, we used R. I wrote a manuscript with one of my colleagues that gave instructions on how to use R. But it turned out that it was really a failure, because we were spending more time telling people, about the syntax. Oh, you forgot this comma, you forgot this parentheses, and we really were not focusing on teaching statistical concepts. So at some point, a friend of mine who is a software engineer and I, we talked, and the idea came up that we put a graphical user interface on top of R, and that's how Rguroo came about. So the idea of Rguroo was that we wanted to provide a software that essentially relieves the students from computing drudgery and and allows them to focus on learning the statistical concepts. And of course, another aim was, R is very powerful, and we wanted to make R accessible to those who cannot write code or don't know how to write code. We were fortunate enough at that time to have also GAIN's technology selection guidelines, and these were a few things that we made sure to pay attention to. Ability to import data in multiple formats, interactive capabilities and dynamic linking between data, graphical, and numerical analyses, ease of reproducibility and integration with word processing and presentation software. So we are really great in reproducibility, as I will show you. And of course, we also have tools for integrating with Word and other word processing softwares. Functional consistency across platforms, and our Rguroo is a web application. All you need is a browser, so it doesn't matter whether you're on Apple or Mac or Windows platform, you should be able to use Rguroo. So additional features that we paid attention to was that you should have accessibility to your data and analysis anywhere and from any computer. These days, we know that students, for example, work different places. They go to Starbucks and work, and then they start in their lab a project, and they want to continue, so they should be able to do that. Ability to share projects, and of course, easily accessible text and video help. I should add to this that we also, Rguroo is completely accessible and ADA compliant as well for visually impaired. So with that short introduction, let me just go ahead and give you a tour of Rguroo and do a few things here in Rguroo. So, all right. So let me begin with our website here. Our website is rguroo.com. And of course, if you just go to the register site, there is a student registration, faculty registration, and non-academic. All faculty, regardless of whether they adopt Rguroo or not, they can get a free account. So there is a login page. I can go to the login page. As I said, you don't need any downloads. You don't need to have R or anything like that. All you need is a browser and the internet. And you just go in and you put in your login information and you log into the application. So let me just move this one to the other side here. Okay, so let me just give you an overview. So we have a data section here, we have plots, we have analytics, and we have probability simulations. I will go into all of these. Then we have this video icon that actually appears everywhere throughout the application, but here is one place where you have access to all the videos. So for example, if I just click here and I type in, for example, let's say confidence interval here, a keyword, I misspelled it. So anyways, if I just open this up, you get, so these are videos related to the confidence interval. If I just double click on this right here, I see, a video that shows up, and this one is about confidence interval for two population proportion.
This video will show you how to make a difference about two population proportions using confidence intervals. If you would like to be hands-on.
And as you can see here, there was closed captions, and all the videos are by default closed captions. Of course, if you want to remove the closed caption, you can do that. All right. So let me also point you to this document here, which is our user's guide. And this is a 400-some page document that not only has many examples, it also explains all the technical computations that are done within Rguroo. So this would be useful for instructors and students alike in case they want to know how things are being computed within Rguroo. So let me just go and introduce you to the sections now. First, the data section. So we have obviously the data import here, where we can, import data. I'll talk about repository, etc. So let me just begin with the data frame import, which is data import. And here you can import either a file from your computer, or if you have a URL, that address, you can put it in there and import it from a URL. there are various formats that Rguroo supports. You can, for example, import Excel, tab delimited, SAS, SPSS, etc. So there's quite a bit of flexibility here. I will work with this in a basic way in a few minutes. The next thing that is really nice that we have is a repository, data repository. There are over 2,000 data sets here. And for example, all the R data sets and all the R packages data sets are available. And so for example, here I can just say, if I say Titanic, there's a data set Titanic, for example, in R, you know, I can click on this information. It gives me the information about this particular data set Titanic, and it says it has 1,313 rows and 6 columns. And once things are in repository, they are pretty easy to import. I just say import, and you can see that within a second, you have your Titanic data set right here. And when it is right here, it means that it is accessible throughout the application. And for example, you can take a look at it quickly, and you can see that down here, it says there are 1,313 rows. You can go and view it. Another thing about the repository is that we have data set for several textbooks. For example, the Hawks textbook here, Discovery, Statistics, and Data. If I just click on that, then, sorry, let me just get rid of the filter here. So these are the data sets there. And, you know, for example, let's say this one is a data set that is CO2 emissions, let's say, that has 14,000 rows. I just select it and I say import, and you can see that within a few seconds, even though it's such a big data set, it becomes available to use. So there is this user-defined or public repositories, private repositories that are also we are working on, and you're going to be able to make your own repositories to share with your classes. That is coming up with our next release. We have data editors, and then there are RGR files for sharing. I will talk about that. Finally, you know, all of our system is in some sort of a tree-based system where you can, you know, store your stuff like in whatever you save in some sort of a hierarchical tree structure where you can organize your material. So that is just a quick overview of data. Let me just go to plots. Again, just a quick overview. We have bar plots, box plots, dot plot, histogram, pie chart, scatter plot, stem and leaf. And so here we can, I can tell you that all of our plots are highly customizable. I will work today with scatter plot and histogram a little bit to show you some of the stuff. In analytics, we have, you know, proportion inference, one population, two population, mean inference, one population, two population. Median inference, similarly, essentially these are non-parametric statistics, linear regression, tabulation, ANOVA, non-parametric ANOVA, and also contingency tables. And we have a pretty strong probability simulation suite. One is essentially a probability calculator for continuous and discrete random variables. And we have random generator, multiple distribution generator, and random selection. So our probability simulation tools are pretty strong if you need to use them. Finally, I should also mention that in the functions, we have different functions. Summary statistics, reshape is essentially to go from wide format to long format. Maybe that if I have time at the end of the talk today, I will use this function. Sort, you could sort the data set. This subset and transform are pretty powerful, and we owe this power to the power of R. You could do pretty nice stuff. Data cleaning, for example, with subset is really handy, and subset is really a handy function for data cleaning or playing around with data. Then we have merge and append as well. All right, so with that, let me just go ahead and start with an example. So the way that I want to start with an example is like how we would do it in class. Well, maybe we don't have it. If you have a data set already in a repository, you can import it, but suppose that you didn't and you wanted to import a data. So I'm going to import a data set that I have already put on my desktop. It's called car data. It's just an easy data set to work with because everybody is familiar with cars. So I'm going to just say open, and it was a CSV file, and Rguroo automatically recognizes the file type. And let me just put a comment on this and say, this is for Hawks webinar. Okay, and we just put that there. And just say upload here. And within a few seconds, the data set gets uploaded. And Rguroo, essentially, when it uploads data, it automatically divides your data into numerical and categorical variables. And in fact, if you just go ahead and right-click here, there's a variable type editor where you can, for example, do various things, reorder levels of categorical variables. There's also the label ID. So for example, in this particular data set, in fact, let me show you. In this particular data set, there's the make and model that you saw was categorized as label ID, and then there's volume, horsepower, miles per gallon, top speed of the car, weight of each of these cars, and then the type that is domestic and import, and then the class that's like subcompact, sport, luxury, etc. So I will be working with this data set here. By the way, notice that anything that I do is a tab within the application and not in the in the browser. It is just every tab is within the application, and you're working all within the application. So it's nice also to always see the summary of the data, so you can validate in some sense whether the data that you imported is okay. For example, looking at the minimum and maximum values, etc. Okay, so let's begin with. Well, maybe I should also show you that here, if I just hover over this, then you see my comment, and then I get the information that there are 82 cases and 8 variables, etc. You could also right-click, and certain functions become available to you here as well. All right, let's begin with a plot. Let's do a scatter plot. So I'm going to select scatter plot here, and I'm going to select the car data that we just uploaded. Now, Rguroo automatically knows that if you're doing a scatter plot, the variables that are going to be in predictor X and Y are going to be only numerical variables. So notice that there are no categorical variables here. So I'm going to choose for my X horsepower, and for my Y, I'm going to choose miles per gallon. Okay. And with just this simple selection, then I'm just going to graph this. And here is the horsepower miles per gallon. Of course, you could just, for example, write, in the x-axis horsepower, and or miles per gallon. And you can, or give it a title, etc. And also, you notice that you see also the correlation between these numerical variables here, right? There are many things that you could do in, with let's say a scatter plot. Let's say I want to identify outliers, and there are different methods of outlier detection. This one is based on, by default, it is based on Mahalanobis distance that some might be familiar with. By default, it's going to identify 3 outliers, and this is case 1, 72, and 78. And for example, you could, let's say, you want to know what is the make and model of these cars, and you just click that, and then now you see that there's a Geo Metro here, Nissan. This one seems to be going out. You could make this graph wider, or now again, talking about customization, you could go to the details. And by the way, all of our functions have basics and details. So here I'm going to go to the details, and this is the tab Identify Outliers. And here you can see that there are various options. For example, the method of identifying outlier by default, as I said, is Mahalanobis, and it is explained what that means in our user's guide. And there are different ways that you can look at. So for example, you want the values that are 3 standard deviation from the mean, etc. So with that, then what I want to do is I want to go ahead and maybe make those labels to go on the top and maybe magnify it a little bit less so that we can see them better. So let's say 0.75. And if I do that, now you can see that everything shows up nicely on the top of on top of each of these. All right, so there is a lot of customization, and of course you could work with things. If you wanted to identify more outliers, you would choose more outliers. Lots of details that you could work here. All right, now let me remove the outliers for a second, and for example, let's put a lowest curve on this to see the different. So this is sort of a smoothed version, and of course, again, in the details, for those who are more advanced, you could determine various parameters for the lowest curve, etc. Again, for the elementary or introductory courses, those are things that probably we don't need. But you can see that the data are nonlinear, and so, well, maybe we want to transform them. All right, so what I want to do now is, let's say I want to take log of the horsepower, and I know ahead of time that if I take log of these, I'm going to come up with some linear. So you can write here, you can write actually any R code if you're familiar with, but I'm just going to use the log function here. All right, so I'll use the log function, and of course now my my x-axis is going to be read log of, and this is going to be log of, right? And so here we go. And so now you can see that I linearized it. And for example, I could just go ahead put a least squares line on top of it. And when I put the least squares line, I get the equation of the least squares line also on the top right here. Okay. So let's say now, let me just remove the least squares line, and let's say that I want to see this for each level of the group class. I could either get one graph for each, or I could just go ahead and put everything on one graph. And now you can see that, there's a legend here, and every one of these classes, every level of the class is represented by a different character and color. And so again, customization, maybe you don't like this to be here. Let's say if you want to move the legend, you go to the legend section, and here maybe you can, you could either put it at any coordinate x and y that you want, or you could say, all right, let's put it on the top right here, and let's make it in, it's too long, so let's make it in 3 columns. Okay. And now you can see that with a few clicks, you're able to do that, right? All right. Now, every one of our functions that involve categorical variable, they also have what we call a level editor. And in a level editor, you essentially deal with specific things about levels. For example, right now, let's say I want to look at the super mini, and I want to make the color of super mini, let's say red, and I want to choose, let's say, a plot character of square filled in squared, and I want to magnify it big, right? So that particular level is going to, that's going to happen, right? Now I made it bigger, and you can see that these two belong to super mini. You could also say, all right, well, maybe I don't want to look at some of these cases, so you could drop some of these levels. And so let's say drop luxury, super mini, and sport, let's say, and just deal with what is left. And now you can see that. Or you could, for example, say, all right, I want to magnify all of these a little bit. So I'm going to go there, and I'm going to come, and I'm going to select all of these, and I'm going to say magnify by, for example, 2 times or something like that. And then you get a magnification. I think that magnification 1 looked better, so let me just go back to my magnification here. The default is 1, by the way, so that is that. Again, you could put in, like, for example, least squares line by each factor. You get the equations up there, and you can see you know, all the lines. Now we can save all of this. So let me just call it car data. Let's say by class. And once you save this, then this is here, and you can at any time log out, come back, and you know, if I just close this and I open it again, you know, I am exactly where I had left off. Okay, and you could continue working with it. So let's just keep that there. The next thing that I want to talk about is let's do an example of an analytic. And let's do let's say one population mean inference. Again, as I noted earlier, you know, there is like the basics and there's the details everywhere. And I will talk about the report layout in a minute. So let's do something simple. First of all, you know, in some of the homework assignments that we give to students, the sample mean is given, the sample standard deviation is given, and the sample size or population standard deviation are given. And if that is the case, the students can simply fill these in, and you know, whether they want to get a confidence interval or do a test of hypothesis, you know, they can just do that with summary statistic. In this case, let me just go ahead and use our data set, car data here. So I'm going to just select my car data, and let's say that we are going to make some inference on miles per gallon. Notice that as soon as I select miles per gallon, the sample mean, the sample standard deviation, and the sample size show up right here. And I want to do a test of hypothesis. For example, here you could just leave it as MPG, or you could say miles per gallon, whatever you want to appear in your report that's coming up. And then you have, you know, you could do normal probability plots, tests of normality, etc. And let's say that I want to test mu not equal to, let's say, 32 miles per gallon. Okay, so, yeah, and then you could, of course, determine your significance level. With that, let's just do a basic Z here. And when I run it, I get a very nice output. I get my data summary with mean and sample standard deviation. I get alternative hypothesis is mean of miles per gallon is not equal to 32. So I get the alternative hypothesis. These are the lower and upper critical values for the critical region. And then I get all of these details about observed Z statistic, the critical values for the Z, and then the p-value here. Along with that, I also get a p-value graph that tells me exactly how the p-value was computed, and those are the red shaded areas here, and the green shows my observed value. The observed value is 33.782, which was the sample mean here. All right, so now let me just talk a little bit about the report layout generator. So I have here this that I started with, and notice that in my report layout generator, it says there's a data summary, there's a table associated with the z-stat, and there is the p-value. Now, suppose that, for example, I want to add a bootstrap t-statistic. So as soon as I select that, it tells me, you know, what is going to appear in the output is bootstrap t-statistics and bootstrap test. You can remove any of these or move them around. So let's say I just want to put this first and put the bootstrap graph next, and then, you know, leave the others below. So essentially, with the report layout generator, you can organize your data, your report as you want. So if I just move that and just say go, now I got a test of hypothesis based on bootstrap t-statistics, and I get the p-value based on bootstrap. I get you know, a nice graph, and then the rest of the stuff are down here. So for example, what I can do is I can say, all right, let's just do this. Let's just you know, I want to just get rid of these, first of all. So, you know, within just a fraction of a second, you see that everything is out. And now let's just save this. So let me just save it as, let's say, car data. mean inference or something like that. All right, so I have it here, so in case I want to come back to it. And then what I'm going to do is I can export this, for example, in Word, okay? So when I just tell it to export in Word, it takes a few seconds, and it's going to generate a zip file. And let's just call this, well, it's called car data mean inference .xzip. Let me just save it on the desktop, and let's just take a look at what I have saved. So here you can see that there is a zip file. If I just double click on it, then it's going to show up here, and this is really what was generated. So here you have an HTML version of the report here that you can open. All right, and so if you just needed an HTML version, also there is all the graphs that are in the report will be there for you in order to import them into your into your other applications here, and of course the Word file is there as well. Okay, so if I just click on the Word file, it's going to open up. Yes, and so here now you have your Word file, right? Just see, I don't know what this is. So now it's in Word, and actually people can go ahead and type in stuff. Notice that the graph isn't there. So if you have older versions of Word, it is going to be there automatically. But with the newer version of Word, at least this is not an issue with Rguroo. This is a security issue with Word. You could just say links and just say save picture in the document. Okay. And you would say select, and then it's going to select the graph, and you have to grant it access. This is a security thing that has been added. And our graphs are big specifically because we just want to make sure that the user has the ability to to have a bigger graph, because it's always easy to make them smaller. All you have to do is just get this, and because you're in Word now, and now I have it here. And for example, you could go in Word and just type in whatever you need. So students can sort of import this and write stuff in Word. So this is about being able to export to Word. All right. So with that, let's go now and do a simulation exercise. Okay. So suppose that, for example, you want to teach the central limit theorem. We have this multiple, let me just close this for a second. We have this multiple random generator where at the same time you are going to be able to generate different types of random variables. And let's say I'm going to be teaching central limit theorem, and I'm going to start with the uniform, generating uniform. So we have a whole bunch of different random variables here, and let me just choose uniform. And let's say that I'm going to generate uniform between 0 to 10, and let me just choose my sample size to be 25. So I'll talk about replication, and seed, of course, is something that if you want to have the same result every time, you just use seed. And usually when I assign homework to my students, I just specify a specific seed so everybody gets the same answer. So let's just see what happens if I just say generate a uniform between 0 to 10. So these are 25 for the sample size 25, sorry, from uniform 0 to 10, right? Okay, now what I could do is I could say replicate this 3 times, and if I just do that, then I say, all right, so here now I have replicated 3 times. That means I have 3 samples of size 25 from uniform. Now I can apply a statistic. So for example, I want to teach sampling distribution and the central limit theorem. So I can, here we have a drop down that has the usual statistics. So let's say I want to determine the maximum of each and the mean of each. So if I just do that, so notice there were 3 samples. So it says uniform maximum. These were These are the maximum values for the uniform random values that I generated for the 3 samples, and these are the means. All right. With that, then we can even do more sophisticated stuff with custom statistic. And here, for more advanced stuff, let's say I want to do and compute the mid-range. And I would simply just type in minimum of x plus max of x, and the whole thing divided by 2. And by the way, here in this space, you can write any code, multi-line code of R, and it will be executed. So for this webinar, of course, I'm not going to go into that. So let me just go ahead and do that. Now you can see that I have the mid-range added here. All right. Then, for graphical purposes, you're going to see later that it would be useful to stack these data, meaning that, I had 3 uniform maximums, 3 uniform means, and 3 uniform mid-ranges. So later I can, if I want to compare these, I can just do that. All right. So with that, now I really want to come up with the sampling distribution of, let's say, maximum, mean, and mid-range. So I have to replicate many times. So instead of 3 times, let's just replicate 10,000 times. So if I do that, it takes only 2-3 seconds, and you can see that it says 30,000 because there are 10,000 cases for the maximum, 10,000 for the mean, and 10,000 for the mid-range that I have calculated. Okay, so now let's save this result. Notice that there are 2 different saves. First of all, it's a saved data set as. So let's call it, for example, CLT25 because I'm trying to show the central limit theorem based on the size 25. So this one is simple because when I just do the save, what happens is this data gets saved as an Rguroo data set, which means that now it is going to be available everywhere throughout Rguroo. Now the other save as essentially saves all the parameters here that you have specified in order for you to be able to come back to it later and work with it. So here I'm going to just say again, let's call this also CLT25. Okay, once I do that, then all the parameters are also saved here. And if I just close this and come back here again, at another time, everything is there and I can continue and work with this. Again, reproducibility here. All right, with that, let's just go ahead and do a graph of what we got. So let's go to the histogram here. All right. And now let's just, that CLT25 is our, it is our data set. And let's just go ahead and graph the values that we have. And let's do it by factor ID, which is essentially the 3 different levels that we had, right? So now you can see that, I have the uniform maximum, uniform mean, uniform mid-range, and I have all the distributions here, right? And so here, for example, I could go to the level editor and, for the uniform maximum, let's say I can just say, label it as distribution of uniform max, for example. I could do different things, change the colors. You could do the bar breakpoints here if you wanted to. And even, for example, I could go to the basics here and say, instead of showing it this way, just make it 3 rows and 1 column. And so now I get, I can simply compare the distributions here. All right. Let's just go ahead actually and make the problem a little bit simpler here. And let's just, for example, focus on the mean only. Let me just get rid of this here and only look at the mean. Okay, let me get rid of the maximum. Okay, it's because I have to just get rid of this sample statistic here. It's here, it's without anything, so let me just get rid of that. Okay. So now I'm just looking at the uniforms, and I'm going to be looking at, so let's just say, call this one uniform only, and call this one uniform only. Okay, I'm going to save both of these. And let's go back to the histogram and just look at this. So I'm going to go to histogram here. And by the way, let's just save this histogram also. Let's call it comparing distributions. Save here. And let me just go to the new histogram and uniform only. And I'm going to just go ahead and get the values here. And I'm going to just now focus on the uniform. Now you can see that now I have the normal distribution that I was expecting. For example, in my class, I can say, well, let's put a density curve on this. And this is essentially a smooth version of the histogram. And let's compare now to the normal. If I were to put a normal on top of it, and now you can see that there is the normal, and maybe the bars are there and they are, you can't see the comparison very well. You could go to the details, for example, and go to this section and say, hide the bars for me. And for example, now we can see that, you know, the distribution of the histogram, which is the green, is pretty well represented by the red. And so essentially showing the central limit theorem. Let's also save this as CLT uniform. Maybe call it CLT 25 uniform, so it's based on the sample size 25. Okay. All right. So this is just an example here of all of this. Now, let me see how much time I have. I should be good now. So let me just go ahead and show you some other features. So suppose that I have done all of this and I just log out here. And, you know, I just go back, and some other time I just use even a different browser, whatever, and I just go back and log in again, right? Okay, so now I have come back. Let's say it's a new class. I have done some work, and here now I have, you know, all of the data sets that we have here. Hold on, let me just look at that. Yeah. All the plots, all the data sets, etc., that we have. And here, notice that if I just right-click on this, on the car data, and I say show dependencies, it tells me exactly what dependencies we have. In other words, what we have done. If I look at the plots, so for example, we did a car, you know, a plot of the car data by class. If I just double-click on it, it just shows up, and this is where I left off, if you recall, right? And for example, I can go back here and say, you know, just remove the LS line by edit, you know, by factor here, right? And it just removes it, right? So it knows that what the dependencies are. Or if I just go to show dependencies again, and I look at the analytics, and here you have the car data mean inference that we did. If I just again double click on this, then you can see that, you know, this is where I left off, and all the parameters that I had selected are here. The report layout generator is here. And not only that, you could also, for example, say, all right, just get me back where I was. Just do, and this becomes, you remember we had done all of these before, and in a matter of seconds, you can see everything that you had done before, and you can start working essentially where you had left off. So this is another nice feature that we have, again, reproducibility. One thing that I want to note is notice that these are in red. As soon as you do a save, you know, it becomes green, so it knows that you have, so you know that you have saved them. And everything has an icon for itself. So, you know, for example, if you look at this icon, you know that this is a scatter plot. And so the icons represent the kind of analysis or graph that you're doing. All right. Finally, another thing that I wanted to show you is that you could share stuff. So let's just go to the plots here. And remember that we had generated these 3 plots, right? Let's say that you wanted to share these. Let me just open and add a folder here. And I'm going to call this webinar. Let's call it Hawks webinar. Okay. You could either copy these, let's say, by right-clicking and copying these files and pasting them to the, you could just copy-paste. But let me just move them actually to the, rather than copying them. And now here I have these graphs. What I can do is I can just right-click here, and I can say export as RGR. So everything that is in this folder can be exported as what we call RGR files. So it says Hawks Webinar RGR, that was the name that is appearing up there. Sorry, this is being covered here. And I can save it on the desktop, okay? So I saved it, and you can see here that this Hawks Webinar RGR showed up on my desktop. And this file you can share with any Rguroo user, and they would be able to open it in their account and see exactly what you have done. So let me just do that with my account. So if I just say go to data and import RGR, I'm going to say choose file. And I know that it is here on the desktop Hawks Webinar RGR. If I just open it, and if I upload it, okay, it says archive file Hawks Webinar RGR imported successfully, and it gives you a date and time. These date and times are GMT, and because we have users everywhere in the world, we just use the GMT time. So one thing that I want you to notice is that this folder showed up here, and you can see that the data sets that I have used, they showed up here, right? Car data, CLT25 uniform only, right? And if I go to the plot section, those were the plots that I shared, and I look at the imported, this Hawks webinar thing this is exactly what I imported now. Notice that this matches what I actually had exported, right? And the user, it could be somebody else, they could just click on this and just see exactly what I have done and continue with where I had left off. All right. So this is essentially a very useful thing. One more thing that I wanted to note is that you notice that, for example, some of the data file names are in bold and some of them are not. For example, Titanic is not bold because I haven't done anything with it. But car data is something that I worked with. Remember the CLT25? If I just right-click on it and I say show dependencies, then what I had done was I had generated the comparing distributions here, and I should be able to essentially open it and work with it, right? So you just double-click on. You need to double-click, and you see this is where I had left off. And so the idea is that you have reproducibility of everything that you have, as well as being able to share projects. This idea of reproducibility turns out to be a very important one in terms of our teaching, because students usually start a project in a lab, and they want to continue at their home or somewhere else, and certainly they can do that by saving their work wherever they are, and they come back and do this. Also, the idea of being able to share it is useful for sharing either with instructors, or other instructors share with their students. For example, in my classes, I save RGRs and I put it on our Moodle or Canvas, and students can use it. So we have found this software to be pretty useful. We are definitely interested in hearing feedback from you guys in order to get an account, as I mentioned, you could just go to the register section of rguroo.com and get an account. Also, all the Hawks products can be bundled with Rguroo as well. So with that introduction, I'd like to stop and see if there are any questions, and I'd be happy to answer. Again, we really appreciate anybody's feedback on these, and we are, you certainly can contact us at support@softletics.com, and we will be responsive to your comments. Thank you, Laura. I think
and if anybody has, of course, anyone has any questions, there's a Q&A box right at the bottom of your screen. You can type those up there, and Mori will be happy to answer those during the live webinar for everyone else to hear as well. So I'll just give it a minute and see if any of those kind of stroll in. Let's see. Now, how much does Rguroo cost for students?
Yeah, so Rguroo is $20 for an annual license. That is from the time that they actually start Rguroo until they end their from the time that they start, they have 1 year, and it costs $20. Also, I should mention something that some of you who use calculators, sometimes calculators are a lot more expensive than this. You know, the calculators that are useful for a statistics class, they run about $70, $80, and you know, for many of the introductory stats courses that we have, you know, we usually don't have engineers in those courses. A lot of them are social science students. They would just spend like $70, $80 on a calculator, and they never use it again. So this is kind of a nice tool, which is, in terms of affordability, it's good. Also, as I said, you know, if you are using a Hawks product, you can ask for bundling your product with Rguroo, and then students will get an access key, and they wouldn't have to pay online. But if they are getting it directly from Rguroo, they can just go to the students section and they can pay online, and it is $20.
Great. All right, any questions from our live audience today? Let's see.
Also, let me also mention that if there are any other questions that at this point, I know some of you guys might be watching this later. If you could just email support@softletics.com. And in fact, if you just go to the support section, contact support here, and you just put your information here. And if you could, if you have any questions, we would be happy to answer. Also, I should mention that one more thing, that support is available for faculty. We can have essentially either individual training for faculty. All you do is you just put you know, your information in the support, and you request the support, and we can certainly have someone come and give you you know, training for Rguroo. And also, if there are a group of people, depending on the location, we could either have an you know, in-person group workshop, or an online group workshop that we can have to train faculty for the you know, for whatever part you actually need help with, or if you need general information.
Yeah, that's perfect. Well, I'm not seeing any questions pop up. Is there anything, you know, before we let everyone go today that you wanted to share? Anything additional?
So as I said, you know, I think that you know, Rguroo has been very useful for us in our university, and as I said, now it is a brand new and state-of-the-art software, and even though it's been just released, you know, in the past few months, we have had great response, and many people actually, now a number of universities have adopted it. And if you have any questions or need any help with Rguroo, please contact our support, and you know, we have a support team that can help you with it.
Perfect. Well, thank you, Dr. Jamshidian, and everyone for attending today. Like I mentioned, we'll be emailing a link to all the sessions at the conclusion of our virtual summit this week. So just be on the lookout for those links to watch back any of these webinars. But thank you so much again for presenting today. And again, if you have any questions watching this after the fact, feel free to contact Dr. Jamshidian directly through the support that he mentioned, or if you have any Hawks related questions, you can email us at marketing@hawkslearning.com.
Thank you, Laura, and I hope everybody stays healthy.
Yes, everyone stay healthy and safe out there. Thank you so much.
Okay, have a good day.
Bye-bye.